Imagine this. You're outside, hoping to catch a glimpse of the great planetary alignment, when you spot something off. A black dot, dead still, and it's getting bigger. Suddenly, news breaks. A rogue black hole, 100 times heavier than the sun, is careening straight for us at 155 million miles per hour. Astronomers scramble to confirm the data. The object's mass and velocity are unprecedented, and its trajectory is a direct hit. 31 hours left for the solar system. The countdown begins, and every planet's fate is sealed by the laws of physics. No, this isn't a Hollywood plot. It's cosmic physics, dialed up to nightmare mode. Let's break down what happens, hour by hour, as this black hole rampages through our backyard. At 0 hour, Pluto doesn't even get a dramatic farewell. The black hole crosses its orbit and tidal forces instantly spaghettify the icy dwarf. Pluto heats up to millions of degrees, vanishing in an X-ray scream. The first domino falls. Scientists explain that the immense tidal forces, differences in gravity across Pluto's diameter, stretch and compress the planet, tearing it apart molecule by molecule. The energy released is so intense it outshines the sun for a brief moment in X-rays. 8 hours in, Neptune's up. Its beautiful blue hue shifts to blood red as gravity distorts its light. This is gravitational redshift in action. As Neptune's light struggles to escape the black hole's gravity, its wavelength stretches, turning blue into crimson. Gravitational lensing paints Neptune across the sky, its moons flung into darkness. The black hole's gravity bends light, creating warped, ghostly images of Neptune from multiple angles. Astronomers watching from afar would see Neptune's image smeared into arcs and rings, a cosmic mirage. In moments, the planet stretched into ribbons of superheated gas. Gone. The process, called tidal disruption, rips Neptune apart, leaving only a glowing, expanding cloud of plasma. Its atmosphere, once calm and blue, is now a storm of atomic chaos. On to Uranus, hour 14. The planet's icy interior boils. The black hole's approach compresses and heats Uranus's core, causing a runaway fusion reaction. The planet, once serene and distant, becomes a cauldron of boiling hydrogen and methane. It explodes outward in slow-motion waves, backlit by the white-hot glow of the event horizon. Astrophysicists theorize that the energy released would rival a supernova, briefly making Uranus the brightest object in the solar system, before it swallowed whole. If you had a telescope, you'd witness an eclipse from hell. The black hole's shadow would blot out the stars, and the dying light of Uranus would flicker and fade, distorted by the warping of spacetime itself. By hour 26, Saturn's iconic rings unravel, spiraling into the abyss. The rings, made of ice and rock, are torn apart by tidal forces, forming a glowing spiral that's quickly devoured. Saturn itself stretches. Its hexagon storm becomes a luminous dagger, and Titan's thick atmosphere is stripped away, layer by layer. Now for Jupiter. Experts speculate that Titan's atmosphere, rich in organic molecules, would ignite in a cascade of chemical reactions, creating a brief, eerie glow before vanishing. Hour 28. The Great Red Spot distorts into an endless scarlet tornado. The black hole's gravity twists Jupiter's storms into bizarre, never-before-seen shapes. The planet's bands and belts spiral inward, forming a cosmic whirlpool. For a brief, blinding moment, Jupiter's metallic core flashes like a newborn star. Then, it's snuffed out. Scientists believe the pressure could trigger nuclear fusion in Jupiter's core, causing it to shine with a ghostly light before collapsing into darkness. The asteroid belt goes wild. With Jupiter gone, its gravitational influence vanishes. Asteroids careen in all directions, colliding and fragmenting, creating a deadly hailstorm of debris that races toward the inner planets. Earth just lost its cosmic bodyguard. Mars? Without Jupiter's protection, Mars is exposed to the full fury of the black hole and the chaos of the asteroid belt. Gone in silence. Global dust storms roar at impossible speeds. The black hole's gravity rips open Mars' crust, releasing ancient reservoirs of gas and dust. The planet's thin atmosphere is stripped away in seconds. Its moons disintegrate into fire. Phobos and Deimos, already fragile, are torn apart by tidal forces, their debris adding to the growing storm of destruction. Olympus Mons, the tallest volcano, evaporates. The heat and pressure are so extreme that the mountain sublimates directly into gas, leaving only a faint shadow in the dust. The solar system's last shield is down. With Mars gone, nothing stands between Earth and the black hole's wrath. Hour 30, 21 minutes. Earth's turn. Scientists and world leaders scramble for solutions. Could we launch an escape mission? Build underground shelters? The reality: there's nowhere to hide from gravity itself. The sky fractures. A perfect black ring, encircled by the debris of shattered worlds, looms overhead. Stars arc and bend. The event horizon is visible for the first time, a boundary beyond which nothing, not even light, can escape. The moon is torn apart, oceans surge skyward, continents warp. Tidal forces raise waves miles high, and the crust buckles. Earthquakes and volcanic eruptions tear the surface apart. The moon's debris rains down, igniting the atmosphere. Time slows and stretches. Your neighbor ages differently to you. This is time dilation, predicted by Einstein's theory of relativity. Near the event horizon, time itself warps. To a distant observer, everything on Earth appears to freeze. Then, darkness. Earth slips across the event horizon. Game over. Some physicists speculate that from our perspective, we'd never see the final plunge. Earth would appear to freeze at the edge, forever. Venus and Mercury try and fail to resist. Their orbits spiral inward, destabilized by the loss of the outer planets. The black hole's gravity overwhelms their own, dragging them inexorably closer. Venus's atmosphere trails like a comet. The thick clouds of sulfuric acid are ripped away, forming a glowing tail that stretches for millions of miles. Mercury becomes a glowing droplet. Both gone in minutes. Mercury's iron core is compressed and heated until it glows white-hot, then vanishes into the void. Finally, the sun. No longer round. Flares whip out, plasma bridges form, then the star is swallowed whole. The sun's outer layers are stripped away, forming luminous bridges of plasma that arc toward the black hole. In its final moments, the sun emits a burst of gamma rays, a last cosmic scream. The last light flickers and vanishes. The solar system is now a void, its history erased in less than 2 days. In just 31 hours, everything gone. Astrophysicists debate, could advanced civilization survive such an event? Some propose building interstellar arcs, others suggest harnessing the energy of the black hole itself. But for us, there's no escape. Could we spot a rogue black hole before it's too late? Could we escape? Drop your wildest ideas in the comments, I'll pin the best one. Some experts say gravitational wave detectors might give us a few days warning, but with current technology, it's not enough. If you thought this was terrifying, wait until you see what a white hole can do. White holes, the theoretical opposites of black holes, could spew matter and energy into the universe. Imagine the chaos if one appeared nearby. Subscribe, because the universe doesn't wait for anyone. And remember, in the cosmos, even the impossible is just waiting for its moment.